Okay, synthetic substitution. Now, we've already talked about synthetic division, and we've used synthetic division to divide polynomials, okay? Synthetic division can be used in a different way also, and I'm going to show you that today. And then we're going to use it again to go back to the polynomials for factoring, okay? So, let's start with looking at this problem. Negative 3x squared plus 5x plus 4 divided by x minus 3. Okay, I'm going to solve this two ways. I'm going to solve it long, and I'm going to solve it with synthetic. Don't worry about, I'm going to go through the long kind of fast, but don't worry because you're not going to have to do it. I'm just wanting to show something, okay? So, x minus 3, what? Yeah, you can go ahead and write it down, but I'm just saying you don't have to worry about doing any of this on your own. Because I figure when I start going through it kind of fast, your instinct's going to be to say slow down, slow down. But, like I said, I'm just going to make a point here with it. All right, so what I multiply x by to get negative 3x squared? Negative 3x. Negative 3x times x, negative 3x squared. Negative 3x times negative 3 is positive 9x. Change your signs. Negative 4x. Bring down the plus 4. X, what do I multiply x by to get negative 4x? So it would be negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. Change your signs. Negative 8. So that's my remainder, correct? And we're not going to write minus 8 over x minus 3 because that's not the point of what we're doing right here. All right, now I'm going to do it with synthetic division. So, do I have any missing terms? No. So, I write down my coefficients, negative 3, 5, 4. What goes right here? Positive 3. You would set this equal to 0, and whatever your root or your 0 is what goes here, which is 3. Bring down the first term. Negative 3 times 3 is negative 9. Combine, get negative 4. Negative 4 times 3 is negative 12. Combine, you get negative 8. So you can see how those relate. So again, my remainder is negative 8. Okay, now let's go back a little bit and talk about evaluating a function for a certain value. So let's say I want to find out let's say I have this function, my original function. Okay, f of x equals negative 3x plus 5x, negative 3x squared plus 5x plus 4. And I wanted to know what the value was when x equaled 3. How would I find the y value when x equals 3? Plug in 3 for x, right? So I'd find f of 3, which means you'd plug in 3 where you see x. Then this would be 3 squared is 9 times negative 3 is negative 27. 5 times 3 is 15 plus 4. And somebody tell me what that is. Negative 27 plus 19, basically. What? So, the whole point of that was for you to see that when you get a remainder, that remainder is the value of the original function evaluated for this number right here. Okay? So, that's what's called the remainder theorem. Now, you can go through and read all this, but basically what it means is if you use synthetic division or you take a factor and you divide by its 0, then you're going to get as a remainder the same number you would get as if you plugged this in and evaluated it using what's called direct substitution. Okay? This is called direct substitution. Plug the number in. Okay? So, Applying the remainder theorem using synthetic division to evaluate a function is called synthetic substitution. It is a convenient way to find the value of a function, especially when the degree of the polynomial is greater than 2. So if you have a polynomial like 8th degree, that's a lot of x's to plug a number in for. Now your synthetic division would be kind of long, but it would probably be a lot quicker than having to stick that value in for a whole bunch of x's and then use your calculator to figure it all out. Okay? So synthetic substitution is just a way to use synthetic division to evaluate for a function. Notice that when we did this, we weren't worried about this was our quotient or any of that. All we were worried about was what we were getting for the remainder. So, in other words, synthetic division can serve multiple purposes. It can be to divide, and now we can see we can use the remainder to actually evaluate for a function instead of plugging it in. Okay? So, we're going to look at an example. We're going to do both methods. We're going to do the synthetic substitution, and we're going to do direct. So, if f of x equals 3x cubed minus 6x squared plus x minus 11, find f of 3. So do y'all want to do synthetic first or direct? Doesn't matter. Synthetic. Okay. So method 1. Synthetic substitution. Okay, look for missing terms. Do we have any missing terms? No. 3, 2, 1, and our constant, we're good. So write your coefficients down. 3, -6, 1, -11. Now, when you do direct substitution, notice we weren't given a factor. We were given an actual number we want to evaluate for. So that's the number you use. You don't use the opposite sign. Only use the opposite sign when it's a factor like x plus something or x minus something where you have to set it equal to 0 to find x. So synthetic substitution, if you're asked to evaluate, that's what you use right here. Okay? Bring down the first number. 3 times 3 is 9. Combine, you get 3. 3 times 3 is 9. Combine, you get 10. 10 times 3 is 30. And what's -11 plus 30? So, according to the remainder theorem, f of 3 is equal to 19. Now, you could also do long division to get that remainder too. But I assume y'all don't want to go there. All right, now let's do method 2, just so you can see. This is called direct substitution. This is what you've always done when you want to evaluate for a function. Or evaluate for a value. Evaluate a function for a value. So if we want to find f of 3, then we take our function and plug in 3 where we see x. So we have 3 times 3 cubed minus 6 times 3 squared plus 3 minus 11. So that would be 27. No, 27 times 3, sorry. 3 cubed is 27. 27 times 3 is 81. Notice over here we really didn't have to use a calculator. Over here you're going to probably need it if you want to do it quickly. All right, 3 squared is 9 times -6 is -54 plus 3 minus 11. Now somebody put that in the calculator. See, now we got to pull out our calculators. Unless you're really good at mental math, then you can do it real quickly in your head. Last year, I could have given that to Dominique, and he would have told me to answer quicker, and he could put it in the calculator. I was always going, all right, Dominique. He'd tell you just like that. All right, so what did we get? So f of 3 equals 19. So once again, you can see that it does work. Now, which way would you prefer with that one? Synthetic. And it's only a 3rd degree. Okay, so you can imagine if you had a 6th or 7th degree. Okay? All right. Now we're going to do a word problem, doing the exact same thing. And one thing you might notice, and this happens, you know, when we do math, a lot of times we're doing really abstract and we work a lot of problems. And those problems have been set up to be real nice and neat. But when you actually do real data, a lot of times you get stuff like this. It's going to be not as neat as when it's set up in the perfect world, okay? So we have this function, c of x equals 2.46x cubed minus 22.37x squared plus 53.81x plus 548.24. It can be used to approximate the number in thousands, that's going to be important in a minute, of international college students studying in the United States X years since 2010. How many international college students can be expected to study in the U.S. in 2025? So we want to evaluate this function for what? C of what? What's our X? Look at it and think about it. Here's a clue right here. So X is the number of years since 2010. And what year are we looking at? So how many years is that? 15. So we want to find C of 15. So let's do synthetic substitution. So do we have any terms missing? No. So 2.46, 22.37, 53.81, and we are going to need a calculator, 548.24. And then what's going to go right there? This number that we're going to be multiplying by each time. Huh? 15. Bring down the first number. All right, somebody, 2.46 times 15. $36.9, thank you. And I have the answers here, so I know if you mess up. Oh, this is a negative. Did y'all see that? I messed up. I forgot to put my negative with 22.37. I'm glad I had my answers over here. Okay, so now combine those two. Does somebody have that done? 14.53. Okay, take that, multiply by 15. 217.95. Combine. 271.76, yes. Multiply times 15. 4,076. Combine. 4,624.64. Okay, so there we go. So now what? What am I looking for? I'm looking for the remainder. So where's the remainder? The very last one. Is that what you were saying? I couldn't tell for sure what you were saying. So that's what I'm looking at. But that's not 4,000, a little over 4,000 students, or between 4,000 and 5,000 students, because this is in thousands, which means we actually have to multiply that by 1,000 to get the actual number of students. So, well, no, it's easy. You multiply by 1,000. How many zeros are in 1,000? 3. So move your decimal 3 places to the right. So that would be 4624640, because you need a 0 on the end to move it 3 places. So actually the number of students expected or predicted to be in U.S. colleges from some other country is over 4.5 million. Now, you could do this. And this could be a way you could check yourself to see if you did it right. And if you plug all that in, you can do it if you want to. I already have, so you can take my word for it or check it yourself. If you plug all that in and you plug it in correctly, you would get 4624.64. Okay? All right. Now we're going to switch gears just a little bit. We're still going to be using some synthetic division, but we're going to go back to talking about the factors part of it. All right, let's look at 2x cubed minus 3x squared minus 17x plus 30, and we want to divide it by x plus 3. So let's use synthetic division. Do we have any missing terms? No. So 2, negative 3, negative 17, and 30. And then what are we going to put right here? Negative 3. And then I'll just be quiet. So what did we get for a remainder? 0. So going back to what we did a while ago, that would tell us that if we plug negative 3 into this function, we would get 0. But that's not our purpose now. Okay, if you get 0 for a remainder, that means that, and we talked about this before a little bit, that means that x plus 3 is a factor of this polynomial. That also means that our new polynomial right here is a factor also. So do you remember what these coefficients go with? How would I make a new polynomial out of those numbers? Good. It's going to be 1 less than what you started with. So you would have 2x squared minus 9x plus 10. Now, since we have a 0 remainder, what that means is if I take this quadratic and I multiply it by x plus 3, I will get what I started with. Because there's no remainder. It'd just be like taking 20 and dividing it by 5. What do you get? 4. And is there a remainder? No. So that tells you that 4 and 5 are both factors of 20, right? What if I said 21 divided by 5? You're going to have a remainder. So that means 21 is not a factor. I mean, 5 is not a factor of 21. And 4 isn't either because you'd have a remainder. Okay? So what I'm thinking. Okay. Now, here's a term that you need to be familiar with. It's kind of a weird term. I kind of get tickled every time I hear it. When you divide a polynomial by one of its binomial factors, now what that's saying is if it's a binomial factor, the remainder is 0. So when you divide a polynomial by one of its binomial factors, the quotient is called a depressed polynomial. And I always think, for some reason, I think sad polynomial. Although that's not what depressed here means. But I don't know. Just kind of weird term to me. All right, a depressed polynomial has a degree that is 1 less than the original, which we already talked about. Okay? So basically, the factor theorem says this. You can read it like this, but basically what this means is if you have a remainder of 0, then the divisor and your quotient are both factors of the original. So here we're looking for 0 remainders. If you're wanting to know if something's a factor, you're looking for a 0 remainder. Okay? All right. Show that x minus 2 is a factor of x cubed minus 7x squared plus 4x plus 12. Then find the remaining factors of the polynomial. All right, so basically they're telling us that x minus 2 is a factor, but we've got to show that or prove it. So how would we do that? Synthetic division, and we should get a remainder of 0. There you go. So do we have any missing terms? Any missing terms? No. So bring down your coefficients. What's going to go right here? 2, because we're given a factor, so you would set it equal to 0 and see what x would be, and it would be 2. So that took care of that first statement there. Show that x minus 2 is a factor. Okay, we did that. Then find the remaining factors. Well, we need to know what this depressed polynomial is. So what are these coefficients? I mean, what do they go with? X squared minus 5x minus 6. Shh. So now we have a quadratic. And if you want to find the remaining factors of a quadratic, try factoring it. Okay? There's no GCF. There's 3 terms. I have a coefficient a leading coefficient of 1. So I bet product and sum will work. X, X. 2 numbers that multiply to give me 6 and combine to give me negative 5. Negative 6, positive 1. So find the remaining factors of the polynomial. There they are. So this polynomial has 3 factors, this original. It has x minus 2, x minus 6, x plus 1. So if you took those 3 and multiplied them all back together using distributive property, you would end up with this. All right, 3b. Show that x plus 4 and x plus 3 are factors of that polynomial. Then find the remaining factors of the polynomial. So we've got to, we're given 2 factors now. It doesn't matter which one you start with. I'm going to start with x plus 4. I'm going to prove it first. So do I have any missing terms? This is supposed to be squared, by the way. Sorry. I had to look that up in the book this morning. That's a typo on the publisher's part. So now do I have any missing terms? No. So 1, 9, 23, 3, negative 36. What's going to go right here? What's going to go right here? Negative 4. And I should get a remainder of 0. And I did. Now, these are coefficients of a 3rd degree polynomial. A 3rd degree polynomial may be hard to factor. But if we could do a 2nd degree, a quadratic, it's going to be much easier. So since this came out even and there's no remainder, we can take these coefficients, because this would be x cubed plus 5x squared plus 3x minus 9 with no remainder. We can take these new coefficients and prove x plus 3. And then when we get through, we'll have a quadratic. So 1, 5, 3, negative 9, and we put negative 3 here. So we just finished that first statement. Show that x plus 4 and x plus 3 are factors. Then find the remaining factors. Okay? Well, now we can take these, because now this would be a quadratic. And if you can ever get it down to a quadratic, Most of the time, you'll probably be able to factor it. If not, you could use quadratic formula to find your solutions if you were going to go ahead and solve it. But right now, we're just going to factor. So, it's no GCF, trinomial, leading coefficient 1, product and sum. X, X, two numbers that multiply to get 3 and add to get, or combine to get 2. Negative 3 and 1 or 3 and negative 1? What?
Plus 3 negative.
There you go.
Minus.
So there's your remaining factors. So this one has 4 factors. It has these 2 that we just found plus the 2 that were given, x plus 4 and x plus 3. So x plus 3 is in there twice. Any questions? I'm not going to hand out the assignment today, so we're done for today. Huh? No, I haven't even copied it yet.